All matter is made up of two very basic components, quarks and leptons. When we move up one more level, we have protons, neutrons, and electrons. Those basic building blocks make up molecules that then form compounds. The compounds then make materials and products that you can buy.
There are 6 types of quarks that occur in pairs or triplets. The pairs are called mesons, and the triplets are called baryons. Baryons form neutrons and protons. The different types of quarks are called up quarks, charm quarks, down quarks, top quarks, strange quarks, and bottom quarks. A proton is made up of 2 up quarks and 1 down quark. A neutron is made up of 1 up quark and 2 down quark. Quarks cannot exist isolated due to quark confinement, which means that when the bond between 2 quarks is attempted to be broken, the bond gets stronger and another pair of bonded quarks is created.
There are also 6 types of leptons that occur in pairs, which form electrons. There are also 6 types of leptons that occur in pairs. Keep in mind that a neutrino is very small with practically no mass, and they never really interact with anything. That will be important later. There are electrons, electron neutrinos, and another set is a tau and a tau neutrino. A tau has more mass than an electron. There's also a muon and a muon neutron. Like a tau, it is more massive than an electron. The fact that a tau and muon are so large makes them unstable. The result of this is that they're not very common. They both quickly decay into much more stable particles.
Like Newton's third law that states that for every reaction there's an equal and opposite reaction, for every particle there is an antiparticle. Antiparticles have the same mass, but they have opposite charges of the base particle. There are numerous different types of charges. There are electrical charges, so an electron would be negative and a positron would be positive. And there are color charges, and that is, the antiparticle would have the opposite color charge of the regular particle.
The types of antiparticles for leptons are antineutrino, antimuon, and anti-tau. Electron antineutrino, muon antineutrino, and tau antineutrino.
One of the most interesting and important aspects of particles and antiparticles is that when they interact, they destroy each other. So, if an electron and a positron interacted, they would both destroy each other. Since they have mass, that mass would be converted into pure energy in the form of electromagnetic radiation. In order to find the amount of energy created, you use the simple formula E equals mc squared. It is important to note that m would not just be one of the masses, but would be both of the masses.
What would happen if a muon and antimuon interacted? It would produce pure energy in the form of electromagnetic radiation. In the current universe, there is very, very little antimatter. However, in the early years of the universe, there was a fairly balanced mix of matter and antimatter.
Overall, without these basic building blocks of the universe, nothing would exist.